work through this. What do I do to be able to pull a variable out of an exponent? What tool do we use? That's what this whole chapter's been about. What tool might we use to pull a variable out of an exponent? Yeah, our log. The log is the tool we're using. Because the b, the p, and the a are all still there. It's just in a different order. So we're going to switch this around into logarithmic form. So we're going to go log base b. What's our base in this case? 10. Log base 10 of our argument, which is 12, equals whatever the power was, 2x minus 1. When we have log base 10, do we have to put the 10 there? Because that's the common log, right? So we're going to put this as, I'm going to zoom this much. So we're going to have log of 12 equals 2x minus 1. Log of 12 is a number. It's a weird looking number, but it's just a number. So we're going to just like pretend I can still get x by itself and keep it as accurate as possible. So we're going to say, all right, how do I get x by itself? Just look at this right side. What do I do to get x by itself? Two x minus 1. How do I get x by itself? Divide 2 is an option. What would be easier first? Add 1. That way I don't wind up with as many fractions. So we're going to go ahead and add 1 to both sides. So we're going to have the log of, and I'm going to put parentheses around it so we're really clear. It's the log of 12 and just 12 plus 1 is tucked on the end. It is not log of 13. It's super duper duper extra important that we make that notation. This is log of 12 plus 1 is different than log of 12 plus 1. Now what do I do to get x by itself? How do I get x by itself down here? Now we're going to divide by 2. So our x is log of 12 plus 1 divided by 2. And that is our most accurate answer. Not super helpful if I want to take that many steps, because I got nothing as to where that might be. So in order to figure out an actual value, what we're going to do is get the calculator. Ooh, and it's being a jerk about the screen again. So we're going to... Oh, it's being super jerk. I love it when it does that. Will it at least let me use the mouse to do it? No, it won't. Ooh, it won't even let me bend it. Sweet. I love that for me. All right, so we're going to go in the calculator. I'm going to point at the buttons for you to hit. So we're going to take our fraction. Oh, there we go. Now my calculator's closed because it was glitching out on me. So let's try the calculator again. See if we can get it to work. So we're going to hit that fraction button at the top. Then you are going to do log of 12 and close the parentheses on the top of that fraction. Once you close the parentheses, you are going to add 1. It's not going to let me do it. And then you're going to divide the whole thing by 2. You're going to put 2 on the bottom. And I'm going to grab a calculator from back here because my calculator decided to wander off. Ooh, I love that. I didn't get all my calculators back. Oh, that's fine though. That's not bad. All right. So we're going to have log of 12 plus 1 over 2. And it should look just like this when you type in the calculator. Log of 12 close parentheses plus 1 divided by 2. And you should have gotten something like 1.039 rounding with 6. So it's really, really important that as you go through and practice these solving things, and as we go through these together, put these in the calculator. If you get to the chapter test and you've never done it before, you will get it wrong. You will. I have never seen anybody get it absolutely right on the very first try, which if you don't ever do the homework or ever do these with me or ever do anything on the actual calculator, that's what you're banking on, is being able to do it right the very first time on the chapter test. And I'm really tired of y'all trying that. Okay? Because we have a chapter test a week from today, next Friday. We're going to do some more solving stuff today. We're going to do a lot of solving with E. It still works exactly the same way that we did the solving the bulwark, the way that you guys did with Ms. Rice earlier this week. And what this is talking about is when we are trying to get variables out of exponents and there's a base of E, it makes most sense to use the natural log. Instead of just switching it around to the common log, use the natural log. That's pretty much the only difference. Because since they're inverse operations, the natural log of E, so if I do ln of E, all it is 1. It makes the E and the ln cancel out. They just go away. Okay, so we're going to look at some of these. We're going to look at solving exponential equations with base E. So get on to page 427, which means get your books out. All right, page 427. Love it, it didn't actually write it in here. Okay. So what we have here is we have an exponential with a base E. And we're asked to solve it. I mean, I want to get what x is. E is just a number. So the first thing we need to do is we are going to look at the left side and we're going to say, how can I get the exponential all by itself? So looking at this step here, this top row, minus 2e to the x plus 3 plus 8. What's going to be the first thing that I move? We're going to subtract the 8. I mean, they kind of tell us that on the side, but yeah, that's 100% what we do. I'm going to color these up because they're just like super small. So we're going to subtract 8 from both sides. Negative 14 minus 8. Again, be careful of your signs, please. I see a lot of people make silly mistakes with this. We get negative 22. Are you cold? Oh my gosh. Say, I am warm today. All right, so then we're going to look over here again. I still want to get that e to the x part all by itself. So what can I do to get the exponential part by itself? What can I do on this side? We're gonna divide. I'm gonna divide both sides by -2 because I'd really like for that e to be by itself. That gives me e to the x plus 3 equals 11. What you have here now is two different ways to think about it. They're the exact same process, but it's a different way to think about it. You can do this exactly like we did the bell work. Switch it around into log form. Log base e of 11 equals this. Or you can use the log as an operation and do the ln of e to the x plus 3 and the ln of 11. I will write it both ways. I don't want you to get confused. One of these you will go, oh, I see what you did there, hopefully. One of these you'll go, what the heck is that gibberish? And that's okay, you're gonna pick one of them. So we can either, I will do this one as an operation. So I'm gonna take my e to the x plus 3 equals 11. And I'm gonna take the log of both sides. Since I have a base e, I'm gonna do my natural log. So I'm gonna do the ln of e to the x plus 3 equals ln, come on pen, of 11. The page we were just looking at, the natural log of e. Those are inverse operations. They cancel out. So we're left with x plus 3 equals the natural log of 11. So this one, I called this one, this is the operation style. This one is gonna be switch forms, where I do my BPA log BAP stuff. So we're gonna wind up with log base e of 11 equals x plus 3. BPA log BAP, I switched it around. Log base e is the same thing as the natural log of 11 equals x plus 3. We wound up at exactly the same place. You can either think of it as switching forms, or you can think of it as an operation that goes on both sides. They mean the same thing. You get to the exact same location. It's just two different ways it pathways in your brain. One of these, you're gonna look at that and go, what magic did you do? And hopefully one of them makes sense. Okay? Because I genuinely have to think really hard about doing it this way. I like it that way better. I have to think really hard about it this way. But I know a lot of people really like doing it as an operation, and that's 100% okay. It works. Okay? Once we get here, both pathways get us to the same point. What do I do next in order to get my x by itself? On either one of these, how do I get the x by itself? Subtract 3. Whoa, chunky pen, holy Batman. Minus 3 from both sides. It's the same over here, minus 3 from both sides. We're gonna get to the same exact answer. So we're gonna have the natural log of 11 minus 3 equals x. Not the natural log of 11 minus 3. They're different. Natural log of 11, period, minus 3. It's super important that you close those parentheses. The natural log of 11, close the parenthesis, minus 3. You should get something like negative 0.6021. Yes. The book really likes us to go for 4 decimal places, which is what I was assuming, and yeah, I was right. So just remember, log is an operation that you can use however we feel we need to. Solve means get x by itself. That's the goal. Let me see if my calculator's being a not jerk right now. Nope, my calculator's still being a jerk. Okay. Love that so much. Questions on this one? Okay. We're gonna do another one. This is the check on 427. Because this solving stuff, honestly, is gonna be a lot of points on the test. Solving things is gonna be a good chunk of it. So first thing we're gonna do on this check, I want to get my exponential by itself, which means I need this 6 to leave. How do I get the 6 to go away? Is it being added? Where are you seeing a plus sign between the 6 and the E? It's being multiplied, so how do I get rid of that 6? Divide. We're going to divide this side by 6 to make this guy cancel out. But that means I also have to divide this side by 6. So we're going to get that e to this really ucky decimal, or really ucky exponent, e to the 0.25x plus 3 equals, and I know it's not going to be easy, but I don't know if it simplifies, 26 over 6. If you type it in your calculator, it will simplify it down to 13 over 3. Because the yellow calculators are awesome. They will simplify your fraction for you. So I've got my e all by itself. I can't deal with the exponent beforehand. What do I do to get my variable out of the exponent? What tool do we use? A log. And again, you can either log both sides, simplify, or you can switch it around to log form. I'm gonna switch it to log form here. So we're gonna go ahead and do our BPA log VAP stuff. That's a B. So we're gonna wind up with log base E of 13 over 3 equals that humongo decimal, 0.25x plus 3. Log base E is also known as the natural log ln of 13 thirds equals 0.25x plus 3. And now all this is a two-step equation that we've been solving since August. The left side is ugly, but that we know how to solve. That we've been doing probably since 7th grade. Or maybe 6th grade, because I know my oldest is doing two-step equations right now. So we've been doing these for a hot minute. So what do I do to get x by itself over here? That's the whole goal. Subtract the 3. That ln of 13 over 3, it looks nasty, but it is the exact same thing as, like, think of it as like pi. We just treat it like that. It's just a weird number. Ln of 13 over 3, and we're subtracting 3 from both sides, so we're going to go minus 3 equals 0.25x. Remember that the natural log is just of the 13 over 3. It makes a huge difference in the values you get if you do that addition or subtraction within the log as opposed to separate from it. I think I've like sat on this desk about 5 times today. So once again, this is stuff we've done for a gazillion years. What do we do to get the x by itself? Divide by 0.25. 100%, that works. Does anyone think of another way to say we divide by 0.25? Not divide by 4, it's the inverse. It's not like a test question or anything. It's just one of those things to make that connection. If we're dividing by a quarter, it's the same thing as multiplying by 4, because those are inverses from each other. It's double division when we're dividing by a decimal. These calculators are, why did I change that decimal? These calculators are good enough to be able to do it. They absolutely can. Totally fine. Especially if you're going to use your phone calculator on homework. Don't ask your phone to do this. It won't hurt your phone, but I can almost guarantee it won't be right. Very few phones can I see that I've ever seen can do this level of order operations on it. So we're going to go ahead and hit on our calculators, hit that fraction button. On the top, we're going to put, so it's going to have our fraction bar. We're going to put our ln, and the calculator automatically opens your parentheses. And you're going to put 13 divided by 3. You can either do it as a fraction or just do it as a division operation. 13 over 3. And then you're going to close those parentheses. Then hit minus 3. You got to close parentheses first. On the bottom of your fraction, put your 0.25. Typing that in, you should get something around negative 6.1347. Questions on these ones where we're using our natural log now to solve. It's the same process that we did with our common logs. We're just a little more skilled in our calculator usage now. So now we're going the other way. Example 5. We've got 1/6 times the natural log of 5x equals 2. Again, I'm going to give us a little more space so I can rewrite, because I write bigger than the book does, and it gets super duper squished if I reuse that. First thing first, I would like my log to be all by itself. So what am I going to do over here to get my log by itself? Which piece do I need to move? The 1/6. How do I get rid of a fraction like that? Multiply by 6. Multiply by what's on the denominator. That means this guy and that guy cancel out. We'll be left with just the natural log of 5x equals 2 times 6 gives us 12. And again, you can think of this in 2 ways. You can either use your BPA log BAP. BP, that is not where that P goes. BP equals A log BAP. That's totally fine. Or you can do a process called exponentiate, which is where we take our base. What is the base of a natural log? That's common log. What's the base of ln? It's technically, but we don't use that. If I switch this like this, well, what I put here, log base, what? What is the base on ln? We need to know this. We did this yesterday. Or we did it Wednesday. It's E. I mean, we just used it over here. We switched log base E to be ln. Right here. So ln has a log base E. So it's the same thing as log base e of 5x equals 12. So we could put it in exponential form. If we switch it around like that, we're going to get e to the 12th equals 5x. Your other option when solving this is to do what's called an exponentiate, where we're going to take our ln of 5x equals 12, and we are going to raise both of these to the power to be powers on e. So e to the ln of 5x and e to the 12th. We said at the very, very first thing we did today, e and ln are inverse operations, so they're undoing each other. And we wind up at exactly the same space of 5x equals e to the 12th. Again, I like switching forms better, but if you don't, that's okay. There's other options. E to the 12th is a funky looking number. That's all it is. So I want you to think over here, how do I get x by itself? Divide by 5. So technically, our answer is e to the 12th divided by 5. That is our most accurate answer. Practicality-wise, it makes sense to put it in the calculator. So, my calculator's being a jerk. To get your e's again, so I know it's been like a chapter since we did that. I hit the fraction button because I know we're working in a fraction. Then you're going to hit the green button up here, the second button, and you're going to hit the ln button. That's going to give you e, and then it'll also automatically pop you up into a power. So we're going to go e to the 12th over 5. And it's going to give you a very big number. 32550 point, and they say 10,000, so it's 4 decimal places. 9583. So 32,550, 9583 is your decimal. Questions on this one? It's just doing the inverse operation. I feel like this is the easier way to go, the switching forms to BPA log BAP, but that's how my brain works, and if that's not how your brain works, that's okay. There's other options. To me, this makes the most sense, but I'm not going to say it has to make the most sense for you because I know these are weird. Okay. So then the book decides you're ready for story problems. I mean, they're not wrong. We're going to do story problems on Monday, but it's a little big of a jump right here. Because what they give you is this gargantuan paragraph over here of story. And all it really states is physics rules about how your soup cools off. Because that's totally something we're going to use in real life. Thermodynamics is fun. So the thing that's weird about this that I wanted to point out is they've got these little sub numbers. It's just a way of notating things that all mean temperature. So we've got our temperature A is the ambient temperature of the room. So they have it as T sub A, which is just annoyingly petty. And this one here is T, so we say that as T naught, N-A-U-G-H-T. Anything with a little 0 as the little sub, we read it as a naught because that's our starting point. So where it's starting is your naught. That's what time 0 is. Okay, and so for this problem, our soup is initially 200 degrees Fahrenheit. So that is our T naught. That is our starting temperature. And our 72 degrees, that is our ambient temperature. So that's the T sub A. And we are asked to figure out how long it's gonna, or what the temperature is gonna be at 30 minutes. So that is little t. Because of course they weren't gonna use any different letters to mean things. Because that would just be ridiculous. Oh my gosh. To use different letters to mean different things? Gosh, who would think that? That's just crazy. So all we're gonna do is we're gonna substitute these values into this equation. So we're gonna take our 72, which was our ambient temperature, and that goes in place of this T sub A, which they've already helpfully done for you. For our T naught, that's what this is, T naught. I'm gonna write it up here, N-A-U-G-H-T, naught. Not N-O-T, is 200, and it's going in place of that T naught. There's another TA. E is not a variable, and then we put our time, T, up in the window. And 30. And for part A here, all we do is put it in a calculator. So we're gonna put 72 plus 200 minus 72. We're gonna put our E back in to the power of negative 0.032 times 30. And it will tell you, and it'll spit out the answer of 121.0103. Calculatory, that's the answer. Realistically, about what temperature is the soup gonna be? Are we gonna say 121.0103 degrees? No. What are we gonna say? How many degrees? How would I say this in real life? It's gonna be about what? How would I say this out loud to a person with a brain? It's about what temperature? About 121 degrees. I would also take about 120 degrees because unless we're talking about a fever, we don't get that specific even usually. So about 121 degrees. When we're putting it into real world context, mostly that just means round it to a practical, I would say it out loud kind of level. I'm not gonna say, my soup is 121.01 degrees. Even I am not that extra. The only time we get that specific on temperatures, on food, is candy making. And even then, it's only to the 10th, not to the 10,000th. Okay? So, the reason that they're doing this and having you care is because when we start getting into story problems, which we're not going to do the rest of this because honestly, I don't want to take us all the way to the bell because ew, it's a Friday. We're going to have times where we're asked to figure out how long until. If we think back to our savings account stuff, how long until it doubles? How long until I have enough to buy this car? How long? Where we're going to be solving for this t, and we need to get the time out of the exponent. What tool would we use to get a variable out of the exponent? Our logs. So if we have a savings account that is compounded in any way, shape, or form, and our time is up in that exponent, and I want to know how long until I can get this car, we use a log. Okay, and that's what we're gonna do next week. We're gonna focus on that next week. Don't worry about this one because honestly, that's really petty. How long until the server brings my soup? Gross. Okay, so now you can finish out homework 484. We did up to 23 on Wednesday, so you should now be able to do these 4. Our chapter test is next Friday. I do have the chapter review, so if you are one of those work ahead kind of people, I will put them out by the turn-in bin so you can grab one on either right now or on your way out. Just because I'd like for you guys to have the chapter review the weekend before. I do not have the answer key for it made yet, but I will. Okay, chapter test is next Friday. Friday's the test, chapter test Friday. All right. Recording.